Alright, this video is about Neptune. So let's talk about Neptune, the most distant planet we have. Neptune has a semi-major axis of 30 AUs. And that gives it a period of 165 years. Which is a long time. Almost double the period of Uranus, which remember was 84 years. The mass is 17 times the mass of the Earth, which makes it very close to the same size as Uranus, and the diameter is almost exactly the same. So that's why we call Uranus and Neptune twin planets. They're almost exactly the same size and mass, just like Venus and Earth are very much similar in size. Density is 1.6 grams per cubic centimeter. And it rotates in around 16 hours. It also still shows differential rotation. All of the outer planets show differential rotation. And you can see there's cloud bands. You can see kind of a lighter region and a darker region, the lighter regions around here. So Neptune definitely has the cloud bands around its equatorial region. Now, the only really good pictures we have of it are these pictures, which are from Voyager 2. It's the only satellite that's ever flown by Neptune. And so we only have a short window there. It only flew by, took a day or two, and that was it. Now, one of the interesting things you see right here is it has a dark spot. I'll talk about it in a second. First, let's talk about how it was discovered. Because it had to be found, you can't see it with your naked eye. You need a telescope to see it. Well, the interesting thing about this one is it was actually predicted before it was discovered. What they were doing is they were looking at, here's the sun, they were looking at Uranus's orbit. And they were watching Uranus go around the sun, and they realized that it was slightly out of position. In one part of its orbit, it kind of made a change in position here. And they're like, well, the only way you could actually make a planet kind of change from its orbit is if there's another object that you're pulling on. So if there's another one and the gravity's pulling on it, it might change its orbit slightly. Or it causes what they call perturbations in the orbit. And so they were like, oh, okay, if that's true, and there's another object out there, let's look for it and see if we can find it. So this was Uranus. And so they saw the weird things in Uranus's orbit, and they predicted that there'd be another planet out there. And this was done by two different people, two different groups of people simultaneously. A guy named John Couch Adams, and he was British. And then a Frenchman, Jean-Joseph Leverrier. Make sure I'm spelling this right. Leverrier. They predicted the position of the planet Neptune. However, they didn't have access to telescopes or any way to go search that region of the sky, so it took a different guy to actually find it. His name was Johann Gottfried Galle. So, this gets kind of complicated. Johann Gottfried Galle. He was the one that actually saw it on September 23rd, 1846. And the amazing thing is he found it within a degree of where it was predicted it would be. He actually used Adams' data, but since they were working independently and came up with it independently back in the time, we give credit to both these people for the discovery of it. Now, one of the more interesting things about this, so this was in 1846. Well, guess what? 165 years later, from 1846, is 2011, if I did my math right there. So, you probably don't remember, but in 2011, to astronomers, there was a big celebration because Neptune had gone around once since it was discovered. It had made one Neptunian year. But if we go back in the records, we see that Galileo had mentioned looking in a very specific spot in the sky in the constellation Sagittarius and seeing a pale blue dot. And he didn't know it was a planet, but what he was really looking at, if we went back to exactly when he looked, that's exactly where Neptune would have been. So Neptune was probably seen first by Galileo back in the 1600s. He just didn't realize it was a planet at that time. All right, so if you're asked who discovered Neptune, you're going to say Adams and Leverrier were the ones that discovered it. But the first one to observe it was Galilei. Okay, that's how we do it now. Because we can't confirm that it was Galileo that actually saw it, but it sure seems interesting. All right. Neptune has, or this Neptune had, I should say, this great dark spot right here. It's a storm, just like the red spot that we talked about on Jupiter. It's an anticyclonic storm, means it spins counterclockwise in the southern hemisphere. This is the southern hemisphere of Neptune. And it's at about 30 degrees south latitude, exactly the same position that the great red spot is on Jupiter. So, formed in similar ways. These clouds are clouds of other material. Now what happens is when it gets really cold, the methane and ammonia turns blue, as we talked about with Uranus. Well, it's even colder once you get out to Neptune. And so it gets so cold out there that it has this dark, deep blue color. And then some of the frozen ice here, that's higher up, actually has that white color. So it's more frozen. They're all frozen ice crystals out at this point. Here's a closer up view of it. You can see it, and not only that, you can see the cloud bands, how it changes down here. Here's another storm down here. These are little storms that showed up. And so Neptune seemed very active. One of the interesting things about this picture, these were some of those clouds, those white clouds. But you can see there's dark off to the side. That's shadows. And by the position of the sun and the shadows not being exactly lined up, you can figure out how high these are. And these are much, much higher. So the clouds are down here, and these clouds are way up high. So there's a big difference in altitude between those clouds. All right, and Neptune has rings. Now again, we had to do the same trick that they did before, that they had to go behind Neptune, fly past Neptune, and look at it from the back and block out Neptune, which was way too bright, to show these thin, dark rings. All the background, that's all stars there. So, what are the thin, dark rings? Well, we know if they're thin, dark rings, they're fairly old rings, which means they're very covered in soot or a carbon type material. And to stay in these thin rings, they have shepherd moons that go around them. Neptune has a bunch of moons. So, not unlike Uranus and Neptune, I think it's like 20-some moons. It's hard to keep up with how many moons they have now. They keep discovering new ones. But that is pretty much Neptune. The way to think of Neptune is think of Neptune and Uranus as being very similar. Neptune's just further away, and so it's significantly colder. Now about that great dark spot, unlike the red spot that's been there for 500 years on Jupiter, the dark spot, when they looked with the Hubble Space Telescope, seemed to have gone away about 10 years later, and we haven't seen it back again. So we always knew these were transient phenomena, but that definitely happened on Neptune. All right, that's it for Neptune. I know I'm whipping through these planets, but there's not a lot of interesting stuff on